All right, so we have some more separable differential equations. This time it's particular solution, so we're using separation of variables again, but this time we've got that added step of solving for C. So this is another circuit activity, so we start with number 1 and then go where that takes us. So for number 1, we have dy over dx equals 2x. So I'm going to start by multiplying by dx on both sides. So then we have dy equals 2x dx. Then we can integrate. So that leaves us with y equals power rule over here. So add 1 to the exponent, you get x squared, and then divide by 2. So 2 divided by 2 is 1 plus c. So that's our general solution, but we want to find the particular solution because they give us this condition here. So y of 1 equals 7, which means 7 equals 1 squared plus c. So 7 equals 1 plus c, c equals 6. So our particular solution is y equals x squared plus 6. To find the next one in our little circuit here, we want to find y when x equals 2. So y equals 2 squared plus 6. Y equals 4 plus 6, which is 10. So that should be our number 2. I'm going to answer number 10 at the top. So that brings us to this one. Should be on your second page. So number 10, well, answer 10. This is now number 2. So for this one, I see that I've got a y and a dy, so I'm going to cross multiply here. So y dy equals x dx. Then I can go right ahead and integrate both sides. So then I have 1/2 y squared equals 1/2 x squared plus c. Multiply by 2 on both sides. Y squared equals x squared plus c. And then take the square root of both sides. So y equals plus or minus x squared, square root of x squared plus c. So our particular solution, it tells us that y of -1 is equal to 8, which means we're just dealing with the positive square root because that's positive 8. If it was -8, then that would mean there would need to be a negative out in front here because a square root is always positive. So the square root itself. So we plug 1 in for x, and then we have 8 equals, oops. So we want to square both sides. So 8 times 8 is 64. And then we have -1 squared is 1 plus c. So c equals 63. So our particular solution here is y equals the square root of -1 squared. I don't know why I just wrote a -1. That should be an x. Sorry. So x squared plus 63. So now to go forward, we need to find y when x equals 1. So y equals the square root of 1 squared plus 63, which is the square root of 64, which is 8. So then we find, well, it's plus or minus 8, but it's plus 8 because that's our only option. There isn't a -8 option. So we find that here. That's now number 3. So we write 3, and then we're going to cross multiply because we have y dy. And then -2 t dt. Then we can integrate both sides. So this is 1/2 y squared equals negative 2t squared over 2. So that's just negative 1t squared plus c. And then to get the y alone, multiply by 2 on both sides. So negative 2t squared plus c, then take the square root. So y equals plus or minus square root of c minus 2t squared. Okay, so that's our general solution. Let's now find the particular solution. So y equals negative 6 when t equals 0. So since that 6 is negative, that tells us we're going to have a negative there. So negative 6 when t equals 0. So we have c minus 0. So that means 6 equals square root of c. So 36 equals c. So our particular solution is y equals negative square root 36 minus 2t squared. And now we want to find t when y equals negative 3 square root of 2. So negative 3 square root of 2 equals negative square root of 36 minus 2t squared. So first thing, I am going to multiply. I'm just squaring both sides. So then we have 9 times 2 equals 36 minus 2t squared, because squaring both sides gets rid of the negative and squares everything all in one step. So that's all we need to do there. So then we have, of course, I'm running out of room. So 9 times 2 is 18. So we have 18 equals 36 minus 2t squared. Subtract 18 from both sides. Negative 18 equals, I'm sorry, subtract 36 from both sides. Negative 18 equals negative 2t squared. I am going to go this way now. So then if we divide by negative 2 on both sides, we have t squared equals 9, which means t equals positive or negative 3. And what we'll find is an option of 3 here. So now that we're here, this is number 4, I'm pretty sure. Yep, we're on number 4 now. So number 4. So this gives us a y prime. That's okay. I'm just going to rewrite it as dy dx. Could be a t, could be an x, doesn't matter. But let's make this a function of x. So here's what I'm going to do here. Let's first multiply by dx on both sides. So negative 4y dx. Now that's a problem because we have a y and a dx. So let's move that y to the other side. So divide by y on both sides. We have 1 over y dy equals negative 4 dx. And now we can integrate that. So when we do that, we get natural log of y equals negative 4x plus c. Do our little trick here with e to get rid of the natural log and get the y alone. So then we have y equals c e to the negative 4x. And then, well, that's our general solution. So now we find our particular solution. So y of 0 equals 8, which means y is 8 when x is 0. So e to the 0th power is just 1. So this is c times 1, so 8 is c, which means our particular solution is y equals 8e to the negative 4x. So to find our next question, we need to find y of 2. So y of 2, just plug in 2 for x. So it's 8e to the negative 4 times 2, which is 8. Also known as 8 over e to the 8. power. And that brings us to the next one. So we find that right here. And then we continue on. So now we're on number 5. So we have dA over dt equals t plus 4. So I'm going to start by multiplying by dt on both sides. So then we have t plus 4 dt. And then I can integrate both sides. So this leaves us with just a. 1/2 t squared plus 4t plus c. So that right there is our general solution. So now we need to find the particular solution using this right here. So a of 2 equals 11. So 11 equals 1/2 t squared plus 4t, plus c. I don't know why I didn't plug the 2 in, sorry. So 1/2 times 2 squared plus 4 times 2 plus c. I don't know why I did that. So, all right, so 11 equals 1/2 times 2 squared is 1/2 times 4, which is just 2, plus 8 plus c. So 2 plus 8 is 10. So 11 equals 10 plus c, which means c equals 1. So our particular solution is a equals 1/2 t squared plus 4t plus 1. And now we need to use that to find a of t equals -5, which means we need to find t when a equals -5. Okay, so -5 equals 1/2 t squared plus 4t plus 1. Then I'm going to add 5 to both sides because we've got a quadratic, so I want it to be equal to 0. Then I'm going to multiply by 2 on both sides because I do not want a 1/2 there because I'm going to see if I can factor this. So 8t plus 12. So then I actually can factor it. So I'm going to go over here and do just that. So 0 equals t plus 6, t plus 2. So this going this way. So then t equals -6, t equals -2. So then you look through your worksheet and see which of those you can find. And what we get is, on the back page, you will find a -2. So that means our answer is -2 because -6 was not an option. So we go over here, we've got -2. So now we are on number 6. So for this is already factored in that way we like it to be factored. We have this first factor has a t and this second factor has a w, so I don't want to multiply anything out because that makes my life more complicated. So I'm going to start here by dividing by w plus 2. So then I have 1 over w plus 2. dw over dt equals 100t. Now my problem is this dt over here because we've got all w's and then this dt. So I'm going to multiply by dt on both sides. So 1 over w plus 2 dw equals 100t dt. And then we'll integrate both sides. All right, so 1 over w plus 2 is going to give us natural log w plus 2 equals t squared, and then 100 divided by 2 is 50 plus c. Let's pause for a second. If this is something that you're unsure about right here, just know that u is w plus 2, so du is dw, and then this is going to be 1 over u, which is why it's natural log of w plus 2. It's natural log of u. So just remember use substitution with that. All right, so now this is our general solution, so we need to find our particular solution. I probably shouldn't have squished this in down here because that's where we're going to write the particular solution. So let me try that one more time. Get rid of that too. It's looking a little cluttered. All right, so we've got natural log of w plus 2 equals 50t squared plus c. So we'll do e on both sides. I'm going to skip a step here. So we're doing e, so that cancels out the natural log, equals c e to the 50t squared. So I skipped a step here. So the e cancels out the natural log here, and I took the e of both sides, but we know, we're thinking a step ahead, we know that this c is going to come down in front of the e. So that's where that came from. So w equals c e to the 50t squared minus 2. So now we've got the w alone, we've got our general solution. Let's find our particular solution. So w equals 7 when t equals 0. So c e to the 0 minus 2. So again, e to the 0 is just 1. So 7 equals c minus 2, which means c equals 9. So c equals 9. Our particular solution is w equals 9e to the 50t squared. Okay, so now we need to find w of 1/5. I think I can squeeze this in here. Let's see. So w equals 9e to the 50 1/5 squared, which is 9e to the 50 times 1/25, which is 9e, and then 50, sorry, I forgot the minus 2 here. 50 divided by 25 is 2, so 9e squared minus 2. Okay, and then we do find that here. Now this one is a doozy, of course, because trig. So let's do this. I'm probably going to have to conserve room here. So now we're on number 7. So for this one, I'm going to do 2 steps in one. I'm going to divide by y squared to get that onto the left-hand side. So 1/y squared dy equals 4 secant squared 2 theta d theta. So I did 2 steps in one. I divided by y squared to get it on the left side, and I multiplied by d theta to get it over here on the right side. So then I want to integrate, and when I do that, I'm going to write this as y to the -2nd, so I can do the power rule. It's not a natural log because this is not to the first power, it's to the second power, which means I can use the power rule. So over here, I'm going to want to do use substitution here because we have something inside the trig function that's more than just theta. So I'm going to let u equal to theta. So then du is 2 d theta. So then 1/2 du equals d theta. All right, so now we have, so this is all going to be multiplied by 1/2, but we have a 4 here, so it's 4 times 1/2. So we're going to have 2 secant squared of u du. Okay, so then power rule over here, you add 1 to the exponent, so that's -1, and then divide by -1. So that's going to give us -y to the -1st equals 2. The antiderivative of secant squared is tangent of u, but I'm going to substitute 2 theta back in. So tangent of u, which is 2 theta, plus c. All right, so now we have negative 1 over y. So this is negative 1 over y equals 2 tangent 2 theta plus c. So in order to get y alone, I'm going to take the reciprocal of both sides and multiply by negative 1. So we have negative 1 over 2 tangent 2 theta plus c. So now I need to use our this information here to find the particular solution. So I need to find c. So 1 equals negative 1 over 2 tangent 2 times theta, which is pi over 8, plus c. So 1 equals negative 1 over 2 tangent pi over 4 plus c. So 1 equals negative 1 over 2. Tangent of pi over 4 is 1 plus c. So naturally, as always, I'm running out of room here. So what happens here is this on the bottom is 2 plus c. So I'm going to multiply by 2 plus c on both sides. So 2 plus c times 1 is just 2 plus c equals negative 1. Subtract 2 on both sides, c equals negative 2. So this went over here. So our particular solution is y equals negative 1 over 2 tangent 2 theta minus 2. So that's our particular solution. Let's circle that. So I'm going to need to do a lot of erasing here. So if you need to write this down, pause the video and write it down, because I need to erase this entire thing here. So that we can find the number to move on to our next part. All right. I'm thinking now there probably was a way to just clear the whole screen, but too late. I've already erased everything. Okay, so backing up, our particular solution was y equals negative 1 over 2 tangent 2 theta minus 3. Okay, so then I need to find y of 3 pi over 8. So y equals negative 1 over 2 tangent 2 times 3 pi over 8 minus 3. So negative 1 over 2 tangent 3 pi over 4 minus 3 is negative 1 over 2. We all know our unit circle, so tangent of 3 pi over 4 is negative 1. So 2 times negative 1 minus 3. And this will leave us with negative 1 over negative 5, which is 1 over 5. So y of 3 pi over 8 is 1 over 5. And that brings us to our last question. So this is number 8. So what I'm going to do here is divide by x on both sides. And then I'm going to multiply by dx on both sides. Now I can integrate. So on this right-hand side, I'm just going to have 1/2 y squared. Then on the left-hand side, I'm going to need to do u substitution. So I'm going to let u be natural log of x. Du is 1 over x dx, which conveniently gets rid of that x in the denominator. So now we haven't integrated yet, so we've got u du once we do the substitution. So 1/2 y squared equals, integrate this, it's 1/2 u squared plus c, substitute u back in, 1/2 natural log of x squared plus c. All right, so now to get y alone, we need to multiply by 2 on both sides. So y squared equals natural log of x squared plus 2 times c, which is we're just going to call that c. And then y equals plus or minus square root of natural log of x squared plus c. So that's our general solution. Now we need to find our particular solution by plugging in what they give us here. So y of 1 equals -2. So -2 equals, since it's negative, we're not going to use plus, we're going to use minus. Natural log of 1 plus c. Now that's very convenient because natural log of 1 is 0. So -2 equals negative square root of 0 plus c, which means we square both sides, c equals 4. So our particular solution is y equals negative square root natural log of x squared plus 4. So that's the particular solution here. So now we need to find x when y equals -5. So let's erase again. So again, this is a video, so you can pause it if you're still writing. All right, I think that's enough erasing. So now we just need to find y when we need to find x when y equals -5. So negative square root of 5 equals negative square root natural log of x squared plus 4. So step 1, I'm going to square both sides. That'll leave us with 5 equals natural log of x squared plus 4. Subtract 4. 1 equals natural log of x squared. Take the square root of both sides. Natural log of x equals 1. To get x alone, we do e on both sides, and that'll leave us with x equals e to the first power, which is just e, which then conveniently brings us back to the answer they gave us for the first one. So that's how we know we're done.